Hi there, it's Alex from Shelf XII. Welcome back, or if you are new here, get ready for a wild ride into the world of computer science. Today, we are shifting gears from our previous game development adventures and diving into the fascinating realm of algorithms, data structures, and those notorious interview questions. In this new series, we'll unravel the mysteries of computer science together and arm ourselves with knowledge to tackle technical interview with confidence. Today we are starting with a classic, the bubble sort. Bubble sort may sound like some kind of funky underwater dance, but no, it's a sorting algorithm. Imagine you have a row of bubbles and you want to arrange them in order from the smallest to the biggest. Easy, right? Well, let's see how this bubbly business works. So we have an unsorted array. Let's bubble up and sort this out. We start with the first element and compare it with the next one. If the first bubble is bigger than the next one, we swap them. Move on to the next bubble. Again, if it's bigger than the next one, swap them. Keep doing this until you reach the end of the row. By now, the biggest number should have bubbled up to the rightmost position. Start again from the beginning, but only go up to the second to last number this time, as the last one is already in its right place. Keep bubbling up. One last time from the beginning up to the third to last number. We only have one more element left to put in place, and our array is finally sorted. And we did it. The elements are all in order. Bubble sort may not be the most efficient algorithm for large datasets, but hey, it's charming, right? Now let's take a closer look at the C# implementation of the bubble sort algorithm that we use to sort our array. We start with the bubble sort method that takes an integer array as input. In the outer loop, we iterate from 0 to n-1. This loop controls the number of passes required to sort the array. On each pass, we'll move the largest unsorted element to its correct position at the end of the array. In the inner loop, we iterate from 0 to the last unsorted element. This loop performs the comparisons and swaps necessary to move the largest element to its correct position. Inside the loop, we compare the current element with its neighbor, and if it's necessary, we swap them. There are few possible improvements, but the time complexity of the bubble sort algorithm is over n squared in the worst and average cases. This is because we have two nested loops, and for each element we compare it with all other elements. Alright, my fellow bubblers, that's it for today's zany algorithm adventure. In the next video we will tackle something even more mind-boggling. Don't forget to like, subscribe and hit that bubbly notification bell so you won't miss it. Until next time, happy coding and keep those bubbles sorted. See you soon.